Okay, we're going to be doing lead code 74, such a 2D matrix. So they're asking us to write an efficient algorithm that searches for a value target in an m by n integer matrix. This matrix has the following properties. Integers in each row are sorted from left to right. The first integer of each row is greater than the last integer of the previous row. So we're looking for a target in this matrix, right? And they're saying integers in each row are sorted from left to right. So in each row, this is sorted, this is sorted, this is sorted, right? And then they're saying the first integer of each row is greater than the last integer of the previous row. In other words, this integer is greater than this. This integer is greater than this. So that tells us that this whole thing is actually one sorted row, right? Stacked on top of each other, like this. It's sorted like this, right? So this, we could have done this in a simple way by simply flattening it, right? So if we figured out a way to flatten it, we're going to use the one in the diagram I'm using here. So I think I can put this away, right? So we can flatten it like this, right? So that we have 1, 3, 5, 8, 12, 20, 25, 30, 34, right? So it will go from having these indices 0, 0, 0, 1 to being 0, 1, 2, 3, 4, 5, 6, 7, 8. Right? So after we flatten it like this, we can do binary search with a pointer here and a pointer there. Right? So how do we do this? Well, we need to first to convert this, we need to multiply, we need to get the total number of values in this matrix. And how do we do that? We simply multiply. I think let me put this somewhere away so that we can have it for reference. I'll put it up here. But what we need, let's see if I can lower it a bit below. Yeah. So what we need is to find the total number of elements in this matrix, which will be the length, it will be the total number of rows times the total number of columns, which will give us, because this is a 3 by 3, the total number of rows and the total number of columns will give us 9. So there's 9 elements, right? And there's 9 elements here. But since we're starting from the 0th index, our start will be at index 0, our end will be at row by columns minus 1, which will be 8. It will be 9 minus 1, which is 8. Does that make sense? This is where our end pointer will be. This is where our start pointer will be. Then, as we traverse through here, we need to figure out a way of converting this back to a value here, right? And the way we do that is, right? The way we convert it back is, let me show you. For, say, if we want to convert this back to its row and column here, we know that we used row times column to get new row, right? So in order to get back the original row, we divide by the number of columns, right? We know we use row by columns to get new row. In order to get the original columns, we have to use modulus. So it will be new row modulus column will give us the original column number. So let me give you an example, right? So, for example, if we're trying to get 5, right? 5, the index is 2, right? What is 2 divided by the number of columns? Okay, the number of rows is 3, the number of columns is 3. So we said in order to get back the row, if we're trying to find the, let me write it like this. If we're trying to find the row and index for 5 in this matrix, right? So in the matrix, we're trying to find the row and column for 5. We know it's at index 2 in the new row. We say new row divided by columns and new row modulus column. So let's see if this works, right? So what is new row? It is 2 divided by the columns, which is 3, and then 2 modulus 3. 2 modulus 3 will give us 2. 2 divided by 3 will give us 0, right? When we truncate. So as you can see, 0 and 2 matches. So essentially, when we create these new values, what we're doing is we're doing 0, 1, 2, 3, 4, 5, 6, 7, 8. Right? So let me code it up so that you can see it, and then we'll come back and draw it again. Right? So let me erase this and erase these. Yeah. Okay, so that's enough explanation, right? Time to code it up. So, time to code. So, first thing let's check that the matrix is not empty. And how do we do that? If not matrix, then we'll simply return false because there's nothing to return. Next thing is we get the number of rows and columns, right? So number of rows, which we'll call rows, is equal to the length of the matrix, and then the number of columns, which we'll call cols, is equal to the length of matrix at index 0. Why do we do it like this? Because this, if we count the number of elements in the first row, then that tells us the number of columns. And if we count the number of objects in the matrix, it gives us a number of rows, right? So then we convert we create pointers. We convert our matrix virtually into a row using 2 pointers. So we'll have here our start is equal to 0, right? Which is going to be, if we look into our start is equal to 0, and then our end is equal to row times cols minus 1, right? If we look at our diagram here, this is what we've done, right? We now have a start pointer here. Sorry, this thing is bothering me. Oh man, okay. My pen is giving me issues. I don't know why. I think I need to recalibrate it or something like that. My pen is giving me issues. So anyways, we subtract 1 because yes, there are 9 elements, but the last index is actually n, right? I mean, it's actually Okay, that has disorganized me. Anyways, we come back here and then we start our while loop. So while start is less than or equal to end, right? So the matrix I was using, right? If you can see, it's 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. But at this index, it's -1 because we're starting from a 0 index, right? Remember that. That's what I wanted to tell you. So while start is less than or equal to end, we calculate our mid, which will be mid is equal to start plus end minus start divided by 2. This is a more efficient way of writing. It won't give us integer overflow issues. Start plus end divided by 2, right? So then we get back the value at mid, right? We get back the value at mid from the matrix, right? And the way we do that is, the way we do that is, let's call it val is equal to matrix at, remember our formula was mid, what we call new row, divided by columns to get the row, and then mid modulus columns to get the column number, right? And I showed this to you earlier. This works out mid divided by mid. What mid is this. What mid is this right here, right? Is the mid value we've picked, this index, right? So now we're trying to convert it back into these two, right? It's unfortunate that my pen isn't working, otherwise I would have visualized this better. So anyways, after we're done with that, we check if val is equal to target, then we have found it, and that means it exists, and we return true, right? Elif val is less than target, then that means we simply increment our start. Start is equal to mid plus 1, else end is equal to mid minus 1, right? And after we're done with this, we'll return false if we haven't found it in this code, right? So let's run this and see. Row is not defined. Okay, my bad. I call this rows. Okay, voila, it works. Right? So that's how we do it. The tricky part here is figuring out a way of converting the matrix into a virtual row, which we do like this, one virtual row, then getting that index from the virtual row, and we calculate our mid using our virtual index. We get back the row and column values from the matrix. The matrix using our virtual mid index, right? So that's how this becomes easy to do. So all right, this has a log m by n solution because of this, right? We just get this whole thing, log m by n, and remember accessing points in a matrix is going to be in constant time, right? So it's log of m by n. Or you can say log of m by, it's log of m by n because we're starting from the 0th index. So yeah, so this is my solution to search 2D matrix. Thank you.